Meet the aye-aye, a unique primate found only in the lush, dense canopies of the forests of Madagascar. This specialized nocturnal omnivore has developed an unusual foraging strategy to locate insect larvae, tapping. Aye-ayes spend the majority of their lives in the canopy. This highly arboreal lifestyle makes them especially vulnerable to habitat loss and deforestation. As a result, they are currently listed as endangered by the IUCN Red List, with populations continuing to decline. Because of this, a deeper understanding of their movement and habitat use is essential. However, a major limitation in current research is that existing techniques do not effectively link movement data with behavioral context. To address this, I evaluated camera traps, GPS radio telemetry, and acoustic monitoring based on 3 key criteria: their effectiveness in solving this problem, the resources required, and their safety for aye-ayes. The first method is camera trapping. This technique involves placing motion-triggered cameras throughout a habitat to capture images of a target species. Camera trapping has several advantages. It is non-invasive, meaning it poses no direct stress or harm to aye-ayes. It is also effective for detecting rare and nocturnal species and can provide brief snapshots of behavior. However, there are notable limitations. Camera traps cannot track continuous movement, and they provide only limited insights into behavior from isolated images. Detection can also be biased depending on camera placement. Additionally, they generate large volumes of data, which can be time-consuming to process, especially in biodiverse environments. Overall, the main limitation of camera trapping in this context is that it provides information on presence and occasional behavior, but not movement. Another method is GPS radio telemetry, which uses collars to track individual animal movement. This method provides high-resolution spatial data, works well in dense forest environments, and allows researchers to estimate home range and habitat use. GPS systems are also automated, making data collection more efficient, although they come at a higher cost. Despite these strengths, GPS telemetry has important drawbacks. It does not directly provide behavioral data. Signal accuracy can be affected by canopy cover, and capturing and collaring animals can cause stress or potential harm if not done carefully. In this case, the primary limitation is that telemetry provides movement data without behavioral context. The final method is acoustic monitoring, which involves recording vocalizations and environmental soundscapes to detect species presence and behavior. This approach is effective for studying nocturnal and cryptic species, provides continuous data over time, and is non-invasive. However, it also has limitations. Acoustic data often lacks precise spatial information, and aye-ayes are relatively quiet, which can make detection more difficult. Additionally, identifying specific behaviors or individuals from sound requires complex data processing and often specialized expertise. The main limitation here is that acoustic monitoring provides behavioral information without accuracy linking it to location. Given these trade-offs, I recommend an integrated approach, combining GPS radio telemetry with an attached acoustic recording device. This method allows researchers to collect both location and behavioral sound data simultaneously. By synchronizing these datasets using timestamps, we can directly connect where an animal is with what it is doing, effectively addressing the core problem. This approach also reduces many of the limitations of using each method independently. However, some challenges remain. Behavioral interpretation still relies on inference, and silent behaviors may go undetected. The system can be costly and requires intensive data processing. Most importantly, collaring still poses risks to the animal, so minimizing stress and ensuring proper handling is critical. Despite these limitations, the ability to link movement with behavior represents a major step forward. This integrated approach can provide the detailed ecological insights needed to guide conservation efforts and help aye-aye populations recover. Thank you to my sources. And thank you for watching. Please feel free to leave any questions or comments below.